This is an introduction to factoring polynomials using a process called grouping. So today's our kind of intro level. We're going to be grouping in pairs. So before we talk about how we're going to factor this, and remember factoring is the process of undoing polynomial multiplication, I want to consider a couple of examples. So the first example is to factor 3y plus xy. So if we were thinking first about the greatest common factor, we want the greatest common factor of both terms, 3y and xy. So since both terms have a greatest common factor of y, or they both have a y in them and nothing else, we would factor out a y first, and then think about our remainder. So visually, we can kind of see what's left over here, right? If we take out a y from 3y, we're left with a 3. And if we take out a y from xy, we're left with a positive x, which means that our remainder is, 3 plus x. And remember, we can always check by multiplying, right? Distributing y to 3 and y to x, and we would get 3y plus xy. So earlier, remember, we talked about factoring out a greatest common factor, the GCF, and leaving behind a remainder. So I want to consider another example of factoring, and this one looks a little bit different. It says we're going to factor the expression 3 times x plus 1 plus x times x plus 1. So again, if my idea of factoring is first centered on greatest common factor, I need to identify the factor or the largest factor that both terms, and when I say terms, I mean the chunks combined by addition here, what they both have in common. And as it turns out, they both have in common this expression in parentheses, x plus 1 and x plus 1, which means that our greatest common factor is that whole expression, x plus 1. Well, and then what remains? Well, if we take out an x plus 1, we're left with 3 and a positive x. So again, we're centering it on this idea of what's the GCF, what's the greatest common factor, and then what is the remainder. So earlier when we were factoring which is the greatest common factor, we were looking at maybe a single term or a combination of coefficients and variables. Now, when we're talking about grouping in pairs, we're looking for a greatest common factor that could actually be an expression. So when we're talking about factoring by grouping, the goal here is to find common factors that may be in parentheses. So that would mean, again, a common factor that's an expression and not just a single term. And so we're going to be grouping in pairs or breaking these polynomials into pairs. And we want to make sure that each pair can be factored using the GCF separately. So right now this is kind of a lot to wrap our heads around, but I think if we see some examples, it's gonna start to make a little bit more sense. So our it says example 3 because there's that third one. It says factor 5x plus 10 plus x squared plus 2x. So what I'm going to do is I've got 4 terms here, right? 1, 2, 3, 4 terms, and I'm going to split it in half into 2 pairs. And I'm going to think about first, what is the greatest common factor of 5x and 10? Greatest common factor of 5x and 10 is 5, leaving behind a remainder of x plus 2, right? 5 times x would give us 5x, and 5 times 2 would give us 10. Next, I'm going to look at my second pair, a positive x squared plus 2x. Notice I left that plus with the x squared. We always want to keep the signs or any pluses or minuses with the term that they're directly in front of. So when I think about x squared and 2x, again, I want to think about the greatest common factor. The greatest common factor between them is a positive x. Now, I know that we don't usually include a plus symbol when we're talking about positive numbers, but in this case, we're going to. We're going to include a positive there to make a note that it's a positive x. And then again, thinking about my remainder, x times what would make x squared? X times x makes x squared. X times what would make 2x? Well, x times a positive 2 would make 2x. So at this point, we should be observing something that just happened. Once we factored out the greatest common factor from both terms, we ended up with this identical expression in parentheses, x plus 2 and x plus 2, which means that for our two pairs here, our two halves of this expression, our greatest common factor is x plus 2. They both have that factor in common. And what remains would be those outside pieces, 5 and positive x. Now, if you're wondering, like, well, okay, so how do I know that this has worked? As it turns out, we have factored this completely. This is the factored form of that original polynomial. The best part about factoring here is that we can always check by multiplying. So if I have factored correctly, right, factoring is the process of undoing multiplication, then multiplication must be the process of undoing factoring. So I'm going to use the box method here to check my multiplication, or to do my multiplication, I should say, and check my factorization. So I'm going to take x plus 2 and, 5 plus x, and I'm going to multiply. So 5 times x is 5x, 5 times 2 is 10, x times x is x squared, and x times 2 is 2x. And when I take all those pieces and I pull them out, I have 5x plus 10 plus x squared plus 2x, which is exactly what I started with. So that must mean that my factored form is correct. So right now, this is kind of a weird little process, but I'd like us to try a couple of examples sort of on our own here and get a little bit of practice. So you try one. It says factor 2x squared minus 6x plus 5x minus 15. And again, our first step is to kind of break this in half and look for the greatest common factor of that first pair, 2x squared minus 6x. So our greatest common factor here is 2x, because 2 goes into both 2 and negative 6, and x goes into both x squared and x. And again, our remainder is what we would get, or what we would need to multiply by to get back to that original. So 2x times x makes 2x squared, and 2x times negative 3 would give us that negative 6x. Next, we need to factor out our greatest common factor of our second pair, 5x minus 15. Our greatest common factor there is a positive 5, and again, I'm including that positive sign there. And then our remainder here is x minus 3. Now, something that's a really helpful hint here is that if we're doing this correctly, right, we have the same expression in parentheses. That's a really good checkpoint to know that we're doing this correctly. So our factored form, we take that x minus 3. Then our second expression comes from those other pieces, the 2x and the plus 5. And here's why it's really important that we have that plus symbol there, because if I accidentally write 2x 5, that is not the same thing as 2x plus 5. So that's why I want to keep that plus there to remind myself that it is going to be addition in between. All right, let's have you try 2. Factor 3xy plus 6x plus 4y plus 8. 3xy, plus 6x have a 3x in common. Since both terms don't have a y in them, we don't include the y in our GCF. And then our remainder will be y plus 2. 4y and 8 have a GCF of a positive 4. So 4 goes into both 4y and 8 with a remainder of y plus 2. So again, when I look at all of my individual pieces here, my factored version is going to be y plus 2 times 3x plus 4. And as it turns out, we could write this in reverse. Also, we could do 3x plus 4 and y plus 2 if we think about multiplication, right? 3 times 2 is the same thing as 2 times 3. So as long as we keep the right pairs together, the order of multiplication doesn't matter. So just a few more examples here, just till we get the hang of this. So 3x squared, 15x minus 2x minus 10. Again, just thinking about those pairs. So 3x squared and 15x have a greatest common factor of 3x, leaving behind an x plus 5. So this time, when we're looking at 2x and negative 10, we're looking at the greatest common factor, which by definition, right, is the largest factor they have in common. Technically, the largest factor that negative 2x and negative 10 have in common is positive 2, right? That's the largest number. So if I factor out a positive 2, let's look at what remains. 2 times what would give us negative 2x? Well, 2 times negative 1x would give us negative 2x, and 2 times negative 5 would give us negative 10. But now we have a problem. Our expressions in the parentheses don't match up. Uh-oh. So sometimes it's necessary to not actually take out the true greatest common factor. Since we want those expressions in parentheses to match, sometimes we have to take out the common factor that's going to make the most sense. So if I want it to be 3x times x plus 5 on the left-hand side, what would I have to factor out of negative 2x minus 10 to make x plus 5 on the right-hand side? Well, instead of factoring out a positive 2, if I factor out a negative 2, that's going to work a little bit better because then I get the same expression in the parentheses, x plus 5, but now when I multiply back through, negative 2 times x gives me negative 2x, and negative 2 times 5 gives me negative 10. So just be careful here. Sometimes it's not actually the true greatest common factor, but the common factor that makes the most sense. 3x minus 2 and x plus 5 would be our factored form. So let's take a look at example 5. Again, split this in half. So 4x squared minus x has the greatest common factor of x. And so when I take an x out of 4x squared, I'm left with 4x. When I take x out of negative x, I'm left with negative 1. Be careful, remember it is a negative 1 there, not a 0, not a blank, or just a minus sign. And then thinking about negative 12x and 3, knowing that I have to have a 4x minus 1 in my remainder, now I'm going to think about, well, is there something I can factor out of both of these that will give me this remainder, and what would that number be? Turns out that number is going to be negative 3. So negative 3 times 4x would give me negative 12x, and negative 3 times negative 1 would give me positive 3. So there's definitely going to be some mistakes that happen along the way. Oops, there's a mistake, right? It'll happen. The mistakes are a totally normal part of this, but remember there's a couple of ways to check, right? We can always check by having the same remainders. So the same expressions in the parentheses, that's kind of our first checkpoint. And then we can always check again our final factored form using multiplication. And I haven't gone through and done that with every example here, but as you're practicing on your own, I think that's a really good idea. So just a couple more examples for you to try here, see how you're doing before you get into your practice assignment. Our greatest common factor of 5xy minus 15y is 5y, leaving behind an x minus 3. 5y times x is 5xy, and 5x times negative 3 is negative 15y. And negative 4x plus 12, we are going to factor out the negative 4, leaving behind an x minus 3. Our final factor form will be x minus 3 times y minus 4. One more example. You try factoring 6x squared minus 2x minus 9x plus 3. So if you're having trouble with finding the greatest common factor, make sure you review that process before you go into your practice assignment. Otherwise, you are ready for part 1 of your practice assignment, and you are ready for our next level, which is actually factoring binomials using this grouping method. So great work, hang in there and let me know if you need anything.